Good afternoon, class. Good afternoon. Thank you. You can sit down. All right, then today we'll be looking at, hopefully, approximation and estimation and how to approximate a number or estimate a number. Before we do that, we have to look at the exercise you were given in the previous lesson on scientific notation. All right, we did the answers to question 1 already. We also looked at questions 2, that's A to J. We completed that last lesson. We are now going to look at question 3. Okay. I asked you, according to your worksheet, to do all the odd numbers, and those are the ones that I think are on the monitor. So letter A, we'll begin from the front. Patrick?
Six times 10 to the power of 7.
Okay, 6 times 10 to the power of 7. Livingston, B?
1.3 times 10 squared.
1.3 times 10 squared is correct. Okay, letter C, Kila?
1.04 times 10 to the power 1.
1.04 times 10 to the power of 1? Are you sure? 1.04 times 10 to the power of 1. Okay. 4 times 2.6 is 10.4. Am I correct? This is letter C. So it's 10.4 times. Then you subtract the indices, which will give, you add the indices, which is 3 plus negative 4 will give negative 1. So it will be 10.4 times 10 to the power of negative 1. But then this is not proper scientific notation because the rule is there must always be 1 digit before the decimal point. So this number is 1.04 times 10 to the power of 1 times 10 to the power of negative 1. So it's 1.04 times 10 to the power of 0. Okay, be careful. Kyle, your answer to letter D.
1.15 times 10 to the power 5.
1.15 times 10 to the power of 5 is correct. Tau?
3.12 times 10 to the power of 5. 3.12 times 10 to the power of 5.
3.1 times 10 to the power of 5. Did you add or divide? Did you add? All of you added? Yes. Okay. Huh? Some of you divided. Okay, we'll have to look at 2 answers then. Because on your worksheet it looks like addition. Is that number 15? Or number 9? Okay. If you added 3.1 times 10 to the power of to the power of 5. Okay, if you add it, then it will be plus 2 times 10 to the power of 3. Then you will have to write this as 31,000. No. 1, 2, 3, 4, 1 more 0. 310,000 plus 2,000. Okay, 310,000 plus 2,000 will be 312,000, which is 3.12 times 10 to the power of 5, which is the answer that Tao gave. If you divided, then you will have to divide 3.1 by 2. Who's got an answer to division if you've divided? Miriam? Pastor Mike. 3.1 divided by 2 and then subtract the indices.
1.55 times 10 to the power of 8.
1.55 times 10 to the power of? Did you add the indices? You're supposed to subtract.
3 to the power of
4.
4.
Okay. 1.88, did you say 88?
55.
1.55 times 10 to the power of 4. Those who divided, you agree? Huh? To the power of 2. Okay, 5 minus 3 is 2. So it's correct now? You all agree? Okay. Letter F. 5.8 times 10 to the power of 3. How many people added instead of dividing? Okay, those who divided? No one divided? 1% divided. Okay, first, see if you can give us the answer if you added 5.8. Let me just rewrite it so we all know what we are talking about here. Okay, if you added 5.8 times 10 to the power of 3 plus 4.9 times 10 squared. Okay, then, did you add? Okay, give us your answer. If your answer is different, then say so we can go through it on the board. Then
6.29 times 10 to the power of 3.
6.29 times 10 to the power of 3? All agree? Okay. Those who divided? Livingston. Since you couldn't get an answer for division. 5.8, okay, if you divided, in case there are some people who divided, let's see if I can do that on the board. 5.8 times 10 to the power of 3 divided by 4.8 times 10, 4.9 times 10 to the power of 2. Okay, you'll have to help somebody with a calculator. Divide 5.8 by 4.9. $1.18367. Okay, we'll just worry about that. And then times 10 to the power of 1. Okay, it's already in proper scientific notation, so leave the answer like that. That's it. Because it's already one digit before the decimal point. Okay, so that's the answer if you divided. Letter G, did everyone divide? How many people divided? 1, 2, how many people added? Most of you added. Okay, let's get the answer for division. $4.017 times 10 squared divided by 3.8 times 10 to the power of 0. Okay, Velma. You added. Okay, let's just see those people who divided. Livingston, did you divide again? Okay, see if you can give us your answer. Somebody check. All you have to do is divide 4.017 by 3.8 and then subtract the indices. Use the mic. Use the mic.
$1.52646 times 10 cubed.
Times 10? Cubed? Okay, if you divide 4.017 by 3.8, do you get exactly this? No? Okay, what do you get? I'd just like to explain it properly. What do you get? Point? Huh? 1%, please. Patrick.
1.0793.
79. True? It's very easy. You just divide 4.017 by 3.8. 1.057. 1. Oh, never mind the other numbers. Okay. 1.0571 times 10 to the power of 2. That's it. That's the answer if you divided. Okay, if you added, because it's not clear on the worksheet, Chutaili, your turn.
4.055 times 10 to the power of 2.
Everyone who added, you agree? Yes. Okay. Next one, letter H. I think it's clear on the worksheet that it's division. Yes. Okay. 4.4 times 10. Sorry, wrong, not 4.4. 4 times 10 to the power of 0. Oh, sorry, 4 times 10 to the power of negative 6. Why? That's if you divide. 8.8 divided by 2.2 is 4, isn't it? Yes. Then minus 3 is minus 6. 4 times 10 to the power of negative 6. Yes. Okay, that's what I said. Letter I, Hekoi. I get this is division as well.
2 times 10 to the power of negative 8.
Okay, correct. Letter J. Velma?
5 times 10 to the power of 3.
5 times 10 to the power of 3, all agree? Yes. Okay, letter K. We?
6 times 10 squared.
6 times 10 squared, correct. Letter L.
6 times 10 to the power of negative 3.
5.6 times 10 to the power of negative 3. You all agree?
9.6.
Oh, sorry. Huh? 9.6? Did you say 9.6? Solomon?
Yes.
9.6 times 10 to the power of negative 3. All agree? Anyone else with a different answer? What's yours? This is for letter L. Huh?
8 times 10 to the power of negative 5.
8 times 10 to the power of negative 5. Any other answers? Okay, which one is correct? Is it 9.6 times 10 to the power of negative 3 or 8 times 10 to the power of negative 5? This one. Okay. The good thing about these two questions is that you can actually use the calculator and then later on change to scientific notation. But remember, in the test, you will not be allowed to use the calculator. Number 4, George. The distance from the sun to the earth is 1.5 times 10 to the power of 8. If light travels at 3 times 10 to the power of 8 meters per second, how long does it take to reach the earth from the sun?
5 times 10 to the power of negative 1.
5 times 10 to the power of negative 1. What's that? Seconds? You all agree? All right, one answer is 5 times 10 to the power of negative 1 seconds. Any other answers? Andrew, what's yours? Same? Lester?
Five times 10 to the power of 2.
Any other answers? No? Okay. The formula to find the distance given the, to find the time given the speed and the distance would be time equals to distance over speed, or it comes from the formula speed is equal to distance over time. Okay, that's generally, physics people will probably tell you that. This is not really correct. Okay, the distance is 1.5 times 10 to the power of 8. But since the speed is in meters per second, you cannot divide meters or kilometers by meters. You have to divide meters by meters. So I have to change that to meters. So I have to multiply by 1,000 or 10 to the power of 3 divided by distance over, we are looking for that time. Time is equal to distance over speed. So that's 3 times 10 to the power of 8. Okay, 1.5 divided by 3 is 5.5. And then 11, that's 8 plus 3 is 11. 11 take away 8 is 3. So 0.5 times 10 to the power of 3. This is rewritten as 5 times 10 to the power of negative 1 times 10 to the power of 3. The answer, 5 times 10 to the power of 2. And make sure you write the units down. It's in seconds. Part B, word problem number 2. The covers of a book are each 0.003 meters thick, and each page is 0.0008 meters thick. If the thickness of the book is 4.6 centimeters, how many pages does the book have? Peter?
500 pages.
500 pages. Anyone else with a different answer? You all have 500 pages. Tricky. Oh, Rita has a different answer.
$200 pages.
200 pages. Any more answers? Boromeo? Yours is 500. Anyone else with a different answer? No? Okay, if I use this book to explain the question. The covers of the book are each 0.003. So this one is 0.003. And this one is also 0.003. Together, they are 0.006 meters. Okay. Each of these pages, so 1, 2, I will not count all of them, 3, each of them are 0.008 of a meter thick. 0.0008 of a meter thick. That's what I said, 0.0008. What, did I put only 2 zeros? Oh, sorry, okay. It should be 4 zeros. If you remove the 2 pages, that means you're removing the 0.006, and then you're going to use the number of pages, the thickness of the number of pages to find the number of pages that are in the book. So if each of these ones are 0.003, that means it's 0.3 centimeters, if I'm correct, thick. So 0.3 plus 0.3 is 0.6. So you remove 0.6 from 4.6. So 4.6 take away 0.6, which is the thickness of the pages you are removing. Thickness of the covers will leave 4 centimeters. That means this is 4 centimeters thick. Okay, each of these pages are now 0.003 4.008 meters. Okay, note the number on the monitor should be 4 zeros before 8. So you divide I'll write it to scientific notation. It's 8 times 10 to the power of negative 5. 5? Okay, this one is 4 times 10 to the power of 0. Okay, 4 divided by 8 is 0.5. And 0 minus negative 5 is positive 5. It's 5.0 times 10 to the power of negative 1 times 10 to the power of 5. How come you got 500 here? What? Should be what? Oh, sorry. Okay, so I have to multiply by 10 to the power of 2. Okay. So it's 4 times 10 to the power of 0 divided by 8 times 10 to the power of negative 3. Okay, that's better. 0.5 times 10 to the power of 3, which is 5 times 10 to the power of negative 1 times 10 to the power of 3. Five times 10 to the power of 2, which is 500. So 500 pages. Okay, next question. The surface area and volume are given approximately by A equals 12.6 R squared and V equals 4.2 R cubed. R is the radius. Okay, the next, then it says the sun may be regarded as a sphere of radius 700,000 kilometers. Calculate its surface area and volume, giving your answers in standard index form. Gabriel, your answer to letter C, please.
.174 times 10 to the power of 12.
6 point. Just repeat it so I can. Six point.
174 times 10 to the power of 12.
Times 10 to the power of 2. Hands up those people who have a different answer. Oh, 12. Hands up those people who have a different answer from Gabriel. All of you have the same answer? Are you sure it's correct? Yes. Okay. Next one. This is what? The surface area? Okay, volume? Quadrille?
.4406 times 10 to the power of 18.
Right, volume 1.4406 times 10 to the power of 18. Everyone agree? Yes? If you have a different answer, then say so we can work it out together on the board. So just so that you make sure it's the correct one. All right, letter D. We got the answer to A already last lesson, and we are going to do the answers to parts B and C. Agnes, your answer, please.
2.7 times 10 to the power of negative 1.
2.7 times 10 to the power of
Negative 1.
negative 1. That's the answer to letter C. Or B. And C?
4 times 10 to the power of negative 2.
You all agree with these two answers? Okay. Next thing we'll be looking at is on approximation and estimation. There are three ways we are going to look at. First one is to estimate a number to the nearest whole number, which you all know. Number two, to estimate a number to so many, and you have to specify the number of decimal places. And then number three, to estimate a number to a certain number, sorry, that should be letter N, to a certain number of significant figures. All right, since you all know about this, I'm going to ask you to tell me how to, or what do you do when you estimate a number to the nearest whole number. So I've got two questions here. The first one is, write the following correct to the nearest whole number. If I wanted to change 26.1 or rewrite 26.1 to the nearest whole number, Garonamo, what do? I don't want the answer. You tell me what I do first.
Look at the number after the decimal point.
And
then run it to the nearest whole number.
Okay, what do you, if I just look at this number and then what do I do? You are telling me to look at the number. Okay, I'm looking at it.
The number that is below 5.
If the number is below 5,
the whole number remains.
okay, so this number will be?
26.
26, okay, the number remains. If the number is greater than 5, like for example 2, I increase the whole number by 1. So if this is 9, 9 is greater than 5, I increase this by 1, so it becomes 29. Okay, you're all experts in this. Next one, write the following to the accuracy stated. Example 1 to 2 decimal places, okay? Siegfried, you tell me what I am to do if I wanted to change this number to 2 decimal places.
You look at the third number after a decimal place. If it's more than 5, you change the second decimal place number, and it's less than 5, it remains the same.
Okay, you told me. Okay. I look at the third number after the decimal point. If it's more than 5, I change it. So the number will be 26.91. Changing is not a real correct number, a correct thing to say. I increase it by 1. If the third number is greater than 5, I increase this one by 1. If it is less than 5, I leave the number as it is. So this to 2 decimal places is 26.92. Well done, Siegfried. Okay. I want to change this to 2 decimal places. Megan. What's my answer?
0.
I've got to have 2 numbers after the decimal point. So it's 0.00. Although the value is 0, I have to indicate 2 numbers after the decimal point. All right, this one, Jake, 2 3 decimal places.
$23.096.
Okay, 23.096. To 3 decimal places, I look at the 4th number after the decimal point. Since it is greater than 5, I increase the one before it by 1. All right, the last way of approximating numbers. Significant figures. Okay, if I wanted to change 0.561 to, okay, we'll look at this bottom one first before we go to these ones. 12 point, sorry, this number is 12. 12.0658. I want to change it to one significant figure. Okay, to one significant figure, the number will have to contain one number which is not 0, which is a non-zero number. So to one significant figure, this number is going to be 10. Okay, this is the rule. You look at the second number in the number. Okay, the second number here is 12. If it is less than 5, the number 2 here is less than 5, then you don't increase this one. All the others will actually change to 0. So this one is 10. Only one here is considered the significant number. Okay, this one, 12.0658 to two significant figures. I will now have to look at the third number in the number. The third digit in the number, I should say. The third digit here is 0. Since 0 is less than 5, I do not increase this number by 1. I leave it, so to two significant figures, this number is 12. Okay, to three significant figures, I look at the fourth digit in the number. Remember, I haven't said anything about the decimal point. It has to be the fourth number, or fourth digit, sorry, in the number. So I'm looking at 6. Since 6 is greater than 5, I increase this one by 1. So to three significant figures, the number will be 12.1. Okay, so significant figures really is not the same as decimal places. Okay, if we'll look at this first before I let you go. 0.561 to two significant figures. Natasha, what do you think?
0.6.
Are you sure?
$1.6.
Okay. The 0 before the decimal point, okay, the number before the decimal point, if it is a non-zero number, it's considered significant. If it is 0, that 0 is considered insignificant. The number will be, you look at the third number, it's less than 1, so the number is going to be 0.56. Again, because this is a 0 number, it's considered insignificant. If it was a number, a digit other than 0, it will be considered significant. Okay, 26.1 to one significant figure. Boromeo, try.
$30.
30. Well done. You look at the second number, it's greater than 5, increase this one by 1. This one, this is a decimal number, which means this 0 is insignificant. Also, this one, because it's a number other than another digit apart from 0 that's after the decimal point, it's also considered insignificant. Daniel, what do you think?
0.0.
0.0?
2.
Okay, good. 0.02. This number is not significant because it's a 0 number. If it's a non-zero number, it will be significant. So you are looking at 5. You increase this by 1. Okay, your homework is exercise A. Write the following correct to the nearest whole number. And exercise B, complete the following tables. The first one is based on significant figures. The second is decimal places. You'll just do those ones, A, B, and C. Okay, the keyword for the pilot teacher is approximation. Good afternoon, class. Thank you.